Okay, this is our is our division of polynomials of one polynomial. This is of order 2, polynomial of order 2 over a polynomial of order 2. If you look at the dominant term is 2 over 2, isn't it? That's dominant term there. So you've got it's akin to 2 over 2. And if you saw that in numerical terms, that would be an improper fraction, wouldn't it? So this is an improper fraction. So in order to get it into a proper fraction, as far as these things are concerned, we need to do division. So we divide x squared plus 2x plus 1, and we divide that into 2x squared plus 4x. And all we do here is we look at the dominant terms, and we ask ourselves, and we do this the same every time, how many of these go into those? The dominant term here, how many of those go into the dominant term here? If we were doing division of, say, 112, right, we'd say, if we were looking at 112 over 7 then, we'd say how many of those go into 1? Doesn't go. How many 7s go into 11? Goes once. 1 7 is 7, and we'd take the difference, wouldn't we? And leave 42. So that sort of process then is very similar to the process we do here. Okay, so let's just get stuck into it then, shall we? So how many of these go into this? Well, you look at the dominant term and you say how many of those go into the dominant term here, 2x squared. So how many x squareds are there in 2x squareds? This is the question I'm asking. How many of these in those? And the answer is, of course, 2. So put 2 there. Then you multiply out, just as we did here. 1 7 was 7. So 2 lots of this then. We got 3 things in a bracket times 2. It's going to be 3 things come out. So 2 lots of that, 2 lots of that, 2 lots of that, yeah? So 2x squareds plus 2 lots of 2x, which is 4x. And 2 lots of 2 is plus 2. Take the difference then. So this take that cancels. That's why we're doing it. This take away 4x. So 4x take 4x. That goes. And there's nothing here, is there? No constant. Take away 2 is minus 2. There we go. Now the remainder that we've got here now is of order 1. It's of order 0 rather. This is of order 2. So we'll have a proper fraction. So we can just write, so what do we have then? Well, we have 2, that's the thing here, plus the remainder, which is minus 2, all over what we were dividing it into, x squared plus 2x plus 1. Hope that makes a bit of sense. It's very similar to the long division of numbers. That's the answer. Let's just go back to this problem, shall we? We said how many 7s in, I won't go into 1, but how many 7s in 11, right, was 1. 1 7 is 7, that was the tens column, and then the 0 here. The difference was 42, and then we looked at this, and we saw it was bigger than 7, so we said how many 7s in 4 doesn't go? How many 7s in 42 then would be 6, and then you times that 6 7s and 42, take the difference, you get 0. So the answer in this case was 16. 112 over 7 is 16. Now here we did a very, very similar process. We started off with a fraction in terms of polynomials. Okay, this is of order 2 over 2, so it's like 2 over 2 here, which is improper, so we can do the division. So we put the thing that we divide underneath here in this position. We're seeing how many of these go into this thing here that's on top. So we look at the dominant terms. That's the key. How many of those go into those? And we asked that question, which was here. We found out the answer was 2. So we put 2 down, and then we multiply through by the 2 all the way through every term in the row. So 2 of these, 2 of these, and 2 of those. There we go. Take the difference. That take that is 0. That's why we're doing it. And then that take that will be 0 in this case, and that minus 2. 0 minus 2 is minus 2. Now our remainder, we look at that every time we do this little process, and we see it's of order 0, just a constant in other words, and so we're finished because that's of order 2. That will be a proper fraction. So this thing went into that twice, yeah, plus the remainder, which was minus 2 over what we were dividing it into. Over what the number we were dividing. Yeah, that's it. That's number 4 done. I know I've gone on a bit, but we'll move along a bit quicker next question. Okie dokie.